Hello and good evening. If you are wondering about what you are about to hear, I'll try to just explain. I've been studying an electronics textbook, and actually I've been reading the same textbook for the last 2 or 3 years now. And I realized that the author of this textbook goes very fast in explaining things, and he didn't always define concepts. So I felt that I would better understand his writing if I went ahead and defined all the technical terms surrounding the things he's discussing. Now he's talking about diodes and transistors, the very scientific essence of them, which is like the p-n junction and the p layer and the n layer. When you sandwich them together, you get like a depletion region in between, and that actually does amazing things with regard to electronics and the applications of just doing that, putting a p layer together, putting an n layer together, and then passing current through it and observing the behavior. Transistors, diodes, even capacitors, and all the various types of different discrete components actually have basis in this phenomenon. So I'm not going to waste any more time talking. And I'm not even going to mention the textbook that I'm reading. If you're studying diodes and some of this fundamental stuff, you might appreciate some of these terms I'm reading. Dopant. Dopant. A substance used to produce a desired electrical characteristic in a semiconductor. Donor impurity. An element which, when added to a semiconductor, provides unbound or free electrons to the semiconductor, which may serve as current carriers. Since such donor impurities have more valence electrons than the semiconductor, a semiconductor doped with donor impurities is an N-type. An N-type semiconductor is created by adding pentavalent impurities like phosphorus, arsenic, antimony, or bismuth. A pentavalent impurity is called a donor atom because it is ready to give a free electron to a semiconductor. The impurities are called dopants. Acceptor impurity. An acceptor impurity accepts an electron from an adjacent atom to create a hole. Acceptor impurities are also referred to as p-type impurities. Common acceptor impurities in silicon or germanium are boron, gallium, and indium. Hole flow. In a sense, there really is something that moves from positive to negative, while the electrons are moving the other way. The hole that the electron leaves behind as it moves toward the positive charge can be thought of as moving toward the negative charge. Majority carrier. The more abundant charge carriers are called majority carriers, which are primarily responsible for current transport in a piece of semiconductor. In N-type semiconductors, they are electrons, while in P-type semiconductors, they are holes. Minority carrier. The less abundant charge carriers are called minority carriers. In N-type semiconductors, they are holes, while in p-type semiconductors, they are electrons. p-n junction. By adding connections to each end of the p-type and the n-type materials, we can produce a two-terminal device called a p-n junction diode, which can be biased by an external voltage to either block or allow the flow of current through it. Semiconductor Basics p-n junction diode. I got these definitions from Google, so they're from here and there. Cathode and anode. A cathode is a type of electrode through which electrons move. Electrodes are an electrical conductor, usually a metal, that is connected to something that is not a metal. The cathode type of electrode delivers electrons, negative charge, and the anode collects electrons, has the positive charge. Forward breakover voltage. The voltage at which device starts conduction is called as forward breakover voltage. In general, this voltage is in the range of 50 to 500 volts. If gate is supplied by a positive current, then forward breakover voltage occurs earlier than no gate current condition. Okay, so the next example I will use is not a definition that I found. It's for the sake of demonstrating what a threshold detector is. I'm not sure I found the best example. I think a circuit diagram would probably be better to show a threshold detector. But I think the textbook I'm reading is really talking about a threshold detector in terms of voltage amplitude as it passes through a diode. Breakover voltage and avalanche voltage, I think that's what a threshold detector would do if you designed such a circuit. Anyways, I didn't spend a lot of time looking into this, but this is one of the first things that came up when I Google searched threshold detector, and it's really talking about AC waves. So here's the Pasternak and Infinity brand website, which shows a threshold detector for microwave and millimeter wave applications. And some of the specs on it I'll just read out loud. Threshold detector frequency ranges from 2 to 40 gigahertz. Input power ranges from -45 to 0 dBm. Is that decibels? I don't know. Extremely fast response times from 45 to 100 nanoseconds. Adjustable and fixed threshold levels. Rugged and compact detector packages utilize field replacement SMA and the small mount type of electronics. Threshold detector series is designed to meet MIL STD 22F environmental conditions. All RF detectors are in stock and ready for same-day shipping. So this is like radio frequency detection, which I guess is on the microwave band. Is that a threshold detector? Maybe. I think I'm probably on the wrong trail as far as finding an example of a threshold detector, because we're really just talking about current passing through a circuit and using a detector in that way. But maybe that's an example of a threshold detector. Anyway, forward bias. This is the next definition. Forward bias. The DC voltage required to maintain current flow in a bipolar transistor or diode, or to enhance current flow in a field effect transistor. For example, a silicon diode will conduct current only if its anode is at a positive voltage compared to its cathode. It is then said to be forward biased. Reverse bias. The applied DC voltage that prevents or greatly reduces current flow in a diode, transistor, etc. For example, a negligible current will flow through a diode when its cathode is made more positive than its anode. The diode is then said to be reverse biased. Compare forward bias with reverse bias. Oh, and these pictures that I think I'm going to prepare and show on the screen, they may or may not be the perfect fit for the definition I'm covering. I didn't spend a lot of time on this video. Depletion region, that's the next definition. In semiconductor physics, the depletion region, also called depletion layer, depletion zone, junction region, space charge region, or space charge layer, is an insulating region with a conductive, doped semiconductor material where the mobile charge carriers have been diffused away, or have been forced away by an electric field. The only elements left in the depletion region are ionized donor or acceptor impurities. Zero bias. Equilibrium. Zero bias. In a p-n junction, without an external applied voltage, an equilibrium condition is reached in which a potential difference forms across the junction. Junction capacitance is the capacitance which forms in a p-n junction diode under a reverse bias. In a normal capacitor, the two parallel conducting plates are electrodes which allow the conduction. When a voltage or potential difference is applied across a capacitor, the charges accumulates at the electrodes. A varactor diode is a p-n junction diode that changes its capacitance and the series resistance as the bias applied to the diode is varied. I'm going to read that again. A varactor diode is a p-n junction diode that changes its capacitance and the series resistance as the bias applied to the diode is varied. The property of capacitance change is utilized to achieve a change in the frequency and or the phase of an electrical circuit. And I know just by having read the textbook that apparently, stand to learn more, these type of diodes can actually be used for very, very high-speed switching, which is interesting because you usually think of MOSFETs or bipolar junction transistors or relays or even microcontrollers for switching, and here you have an instance where you have a varactor diode which apparently can oscillate between on and off very, very quickly. Or I could be wrong in my ideas. The next definition is very similar to the one I've just read. The one I just read was varactor diode. Now I'm going to mention the varicap. In electronics, a varicap diode, also known as a varactor diode, variable capacitance diode, variable reactance diode, or tuning diode, is a type of diode designed to exploit the voltage-dependent capacitance of a reverse-biased p-n junction. Avalanche breakdown. Avalanche breakdown is a phenomenon that can occur in both insulating and semiconducting materials. It is a form of electric current multiplication that can allow very large currents within materials which are otherwise good insulators. It is a type of electron avalanche. The avalanche process occurs when carriers in the transition region are accelerated by the electric field to energies sufficient to create mobile or free electron-hole pairs via collisions with bound electrons. To me, that's not such a great definition. To me, and from what I've read, a simpler explanation of what an avalanche breakdown would be is I guess when something is reverse biased. You know what, I better not take a guess at a definition. Not the time to do it. Not when I'm recording. Okay, a Zener diode. That's my next definition. A Zener diode is a particular type of diode that, unlike a normal one, allows current to flow not only from its anode to its cathode, but also in reverse direction when the Zener voltage is reached, period. Zener diodes have a highly doped p-n junction. Here's another definition of the same thing. Here's definition 2 of a Zener diode. A Zener diode is a special kind of diode which permits current to flow in the forward direction as normal, but will also allow it to flow in the reverse direction when the voltage is above a certain value. The breakdown voltage known as the Zener voltage. Next definition. A rectifier diode is a two-lead semiconductor that allows current to pass in only one direction. That actually just sounds like the definition of a diode. But I guess diodes are used in rectification, so that makes sense. A rectifier diode is a two-lead semiconductor that allows current to pass in only one direction. Many types of diodes are used for a wide range of applications. Rectifier diodes are a vital component in power supplies where they are used to convert AC voltage to DC voltage. For rectifier applications, peak inverse voltage or peak reverse voltage is the maximum value of reverse voltage which occurs at the peak of the input cycle when the diode is reverse biased. The portion of the sinusoidal waveform which repeats or duplicates itself is known as the cycle. That was the definition for peak inverse voltage. I found another definition, as that one seemed a little complicated. So here's definition 2 of what peak inverse voltage is. Here goes. The peak inverse voltage is either the specified maximum voltage that a diode rectifier can block, or alternatively, the peak inverse voltage is the maximum voltage that a rectifier needs to block in a given circuit. Okay, thank you for listening. Hope that was helpful. Electronics, diodes, p-n junction, diodes, p-n junction, diodes, transistors, diodes, transistors, diodes, transistors, diodes, transistors, capacitors, diodes, capacitors, diodes, capacitors, diodes, capacitors, diodes, p-n junction, transistors, p-n junction, transistors, p-n junction, transistors, p-n junction, transistors.